Stability of an oscillator is the degree of uniformity of frequency of the oscillator when measured over time. Frequency can change with change in conditions like temperature, load, and supply voltage. For better stability of oscillators, temperature, load, and supply voltage should be stabilized. Load can be stabilized by using buffer amplifiers between the oscillator and power amplifiers. In my early era of homebrewing in amateur radio, drift in frequency of the variable frequency oscillator was a tough problem to handle. Drift in frequency of the oscillator would cause difficulty to other stations listening to us, as they had to continuously track our transmit frequency by manual tuning of the radio. When there were multiple stations on a round table, if the frequencies of each station drifted, that would be a real mess and could cause interference to stations working on adjacent channels. Drift in frequency could be due to change in inductance and capacitance in response to environmental conditions like temperature. Change in capacitance of the components with change in temperature could also contribute to drift in frequency. A simple way to improve stability was to use crystal controlled or simply crystal oscillators. These were based on the piezoelectric principle, in which quartz crystals would vibrate at a stable frequency when fed with the radio frequency current at its resonant frequency. The crystal shown in the previous image has a resonant frequency of 26 MHz. Disadvantage of crystal oscillators for amateur radio operators would be tethering to single frequency operation. I have operated on CW with crystal oscillators long back with good frequency stability. Even frequency of crystals can drift with change in temperature, as the quartz crystal can expand or contract. That is why in high precision equipment, crystal temperature is controlled, typically in a warm chamber known as crystal oven. Then they are called oven controlled crystal oscillator, OCXO. Other methods of stabilization are with analog circuits to compensate drift in frequency with temperature, known as TXCO or temperature compensated crystal oscillator, and microcontroller compensation known as MCXO.